Okay. Everyone can hear me, listen to me in the Zoom. Guys, you all can hear me, right?
Yes.
Yeah, bro.
Yeah, but I don't know about these guys. Oh God, what to do? Okay, you guys will. Oh, okay, fine. Okay. So today what we are going to study is week 2, which relates to data model. How will I teach? Okay, try to see that. I will just put my glasses out so that I can also see the distance. Okay, so today we are going to study a topic which is very essential for a big data. Okay, that topic is called as MapReduce. Okay, it's a core part of your test. I would call it core part of a big data which is being implemented across the organization. Okay, what we are going to divide this section is 1 hour. I will just go over the slides. Okay, and the remaining 1 hour or maybe 40 minutes, I will show you how to do it in the machine. Okay, as I told you in the last class, be patient when you do it installation on your machine. Okay, I will show you the step how to do it, and there is a documentation. I will send it as part of your announcement, right? You watch that, look at the announcement, follow the step-by-step screenshot and do it. Okay. So there is some recommended source to read, which is from the University of North America, HPCC system, models for big data, white paper. Again, you can, why it is not coming in the screen. Visible now? I hope you all can see this one a little bit better. Right? Okay, I think what you can do, you all can come that side. Again, the audio will go away. Okay. You all can see that, right? I don't know how much you can, but anyways, don't worry, I will just. Sorry?
We have the material with us.
Okay, then it's fine. You can open the material on your. So the concept of big data has one more aspect, which is called as big data modeling. Okay, you cannot use big data unless you know how to model the data. Okay, so big data modeling contains two terminologies, specifically big data and data modeling. The term big data is related to massive amount of data created by enterprise in the contemporary world. Enterprise can't analyze the kind of data using conventional method. Last class I told you the standard procedure of storing the data in a regular database management system. It's good enough for some gigabytes, a few hundred gigabytes, but for the massive amount of data which is not in a structured format, the big data concept helps. Okay, these difficult data types can be analyzed through high quality data modeling technique. In this regard, we have to understand the data modeling means arranging a data in such visual pattern that the data analysis process can be carried out efficiently. Okay, the technique contains the process of developing a visual representation of complete or a part of data set. Okay, so basically data modeling is a technique by which we can simplify the data which is there in form of an unstructured format. Okay, in a normal format, you can understand that this column is the name, this column is the age, this column is the whatever salary, right? But in case of unstructured data, you have to have a modeling in place which can help you to understand the feature and data specific content. Okay, for that, we simplify using data modeling technique. Okay. So we use the data, again, I'm going through this theoretical things pretty quickly, not a very important aspect, but just understand the basic of it. The important concept will come later on. We use the data modeling due to the following reason. Data interpretation can be enhanced through the visual representation of data. So data modeling helps in data interpretation in a visual form. Okay, it helps to understand the data more in a better way, I would say. The data model gives a clear idea of a market requirement. As I gave you an example that how many people of certain age group use certain type of product. If you can classify data into that model, you can clearly, easily understand the requirement that needs to be created. The data model property represents a critical data in an organization, data omission problem are eliminated due to data modeling. Again, when you get a raw data or an unstructured data or a semi-structured data, you simply don't delete the data. Maybe some data, if you want to remove it, may be required later on, right? So basically the intention is not to eliminate or omit any form of data, just to keep the data as it is in a raw format. Whatever you need to use, you use it, but don't remove or omit any other thing. An efficient data model assures persistent throughout an organization project to improve data quality. So basically it's persistent, it's not going to get expired or removed. It helps us to develop a tangible interface that integrates the data in a unified platform. It also helps us to find duplicate, incomplete, and redundant data. So these are some of the features of data model. Stored procedure, relational database, and foreign and primary key are all explained in it. It's the same concept what you use in the database management system. It also assists project manager in getting quality control and greater reach. It also improves overall performance. So basically, these are the qualities of a data modeling technique. Three things I would like to explain you before I go to the next slide. So can someone explain me the difference between the database, data lake, and data warehouse? It's okay. If you don't know, just tell me, I know this, I know this, I don't know this. How many of you know database? Everyone pretty much knows what is a database. Database is a collection of records stored in a table format in a structured way, right? That's a basic database concept, right? Think about a scenario where I have got 50 databases and I want to merge all the database to get one entity. That's called as data warehouse. Okay? Warehouse, you understand, it's like a storage area, right? So think about there is one data from, let's say I give you an example, one data from a core banking of a bank. Core banking like you and me doing a banking transaction. One data is for people on the same bank using the bank system to do trading. Okay, there may be one system which is holding the data which is related to, let's say, insurance of the company. Insurance, you purchase insurance, right? All these three data are stored in three different databases. Let's say data one is stored in SQL Server, data two is stored in Microsoft, data two is stored in Oracle, data three is stored in third type of database, let's call this a Sybase. Okay, now if I'm merging all the three databases to get one entity of the volume of data, that is called as data warehouse, right? So when I'm creating a data warehouse is used for analytical purpose. When I say analytical purpose, means to take out some relevant information in terms of how the sales is going, right? How the usage is happening, right? The difference between a database and a data warehouse is database is a real-time data. So whatever you do an insert, update, delete on that database, it's directly affecting the database, right? It gets inserted, it gets updated, gets deleted. What is data warehouse? Data warehouse is near real-time database. So whatever is stored in all those ABC databases, do I have a marker? No, I don't have it. Next time, remind me, I will bring a marker. So in case of data warehouse, the data is periodically updated on the destination. So if you have 4 databases, all the databases are having an update real-time information. That information gets reflected in the data warehouse after a job is run. When I say job is run, like a batch job, like ETL process, right? So you'll find the data warehouse of a big organization, the batch is running in the night. So what they are doing, they are taking the information from all the databases and running a batch job in the night to upload the data into the data warehouse, right? The data warehouse will have the information with the latest and the greatest when the last execution of ETL job has run or last process to load the data has run. It never had the data of the real time which is stored in the database. Is this clear? Okay. So the third one is database, second is data warehouse, third is called as data lake. The difference between data warehouse and data lake is data lake consists of databases of different type and different data set, both structured as well as unstructured. Data warehouse only considers structured data format collected from different sources when the process runs. But data lake consists of data of any format. Okay. So here the Hadoop concept comes into picture, is form of a data lake or a big data. Okay. Now yes.
So which one is the broader term, like data lake house or data lake or data warehouse?
They are all independent things. Okay. Each and everything has an use, advantages and disadvantages. So don't think our data lake is the best among all. No. Data lake is good when you have a huge amount of data and you need a scalability to go up to infinite level. Right? You have a system where you are not going to have, you don't want to get into a problem of scalability in future. Your volume is growing at random pace and you cannot control the volume, but you want to make sure that no data is eliminated. I keep everything, whether it is a video file, whether it is an MP3 file, whether it is a bitmap file, JPG, image, whatever data I have, I want to keep everything. I will figure it out how to extract. That's my problem in data lake, right? In case of data warehouse, the advantage is you get the consolidated view or 360 view of the data information across your organization and enterprise, right? So I might have a EDW or enterprise data warehouse where I know the information across my line of business, right? Although I am growing at certain speed, but not at the speed of the data lake. Also, I am growing, but I have a structured format. I know I'm getting the source information from all the databases which has got a structured format data, right? When I do the ingestion or when I load the data in my data warehouse, I know that tables will be loaded properly because everything is being structured format. Clear? So that's the advantage of data warehouse. And advantage of database is fast, reliable, quick update. You know my database has to update the information in real time. I cannot wait for 10 seconds, 20 seconds. Use an independent standalone database, have the data inserted on that database on a real time, get the information on your application. You want to send that information to data warehouse, write a batch job that runs in the night, which just take that information and load it into the data warehouse. Is this clear? Okay. Any question on this? Okay. So big data models, the principal performance driver of a big data application is the data model in which the data resides. So there are three basic types, and the fourth one is called as text. So if I draw a chart, the left hand side is called as structured data. Structured data means a data which is very much clean, very much defined, right? And has got a preset data parameters, right? For example, data parameter like integer, float, data types are very clearly defined. You know where the data will get inserted into which column, right? That's the best part of the data, cleanest part, right? If you go on the right hand side completely, the data is called as text. Text means visual speaking, right? How we are talking, right? Which language I'm speaking, what email I'm typing, the content of the email, the semantics of the email, that data is called as complete text, right? Even if you click on any web page, have you ever clicked on any of the browser and right click view source? So you will get an HTML tag. That's also somewhere close to unstructured, but not completely text, because you can still extract the value with the tags, right? Removing the tag and you can filter out the content out of it, right? The worst form of data is a text, which is very difficult to interpret. The best is the one which is on the left hand side, which is structured. In between, you get something called as semi-structured and unstructured format. Semi-structured data are the data in which some portion of data will be structured and some portion will be unstructured. Okay? Anyone know the example of it? Structured is very simple, right? The data of employee table, inserting a table, that's structured. Unstructured data may be completely different, like your example, media, email, online reviews, right? Unstructured, people can write any content, right? What is semi-structured? Something which has got some structure and some portion unstructured. Any idea? Yes. Twitter tags. Twitter tag. Because when you hashtag it, the tag portion is structured, right? That resembles any specific content. And then the content within that may be any arbitrary comments, right? Simplest of the example of semi-structured data will be your classical email. Have you ever added a rule in Microsoft Outlook? Anyone? Anyone has not done, you let me know. Not done. So if I have my email, right, and I want that email from my boss goes to a specific folder, what will I do? I will create a rule. If the sender is this, I put his email, then send this email to this folder, right? If my team sends me an email or a person sends me an email, I will say, okay, find this email address. If that email is coming from this source, put it in this folder. What I'm doing, I have a structured portion that has got to, right, or from, and a content folder that says a body of the email, which I cannot interpret, right? So that's called as semi-structured data. Okay, right? Twitter also you can use. Another example would be, what should I say? Twitter, you can say folder organized in your laptops. So what do? You create different folder, right? So let's say I created a C drive. I have created a folder called as notes. Then I created a folder called as quizzes. I created a folder assignment. Whenever you do assignment, what do? You put it in the assignment folder, right? So assignment is your structure. The folder file which is created is unstructured, right? So that's pushed inside that folder, right? Is this clear? Okay. In case of structured data, there are 3-4 different types. I think 3. One is called as hierarchical. Hierarchical, you know, right? It's like a hierarchical structure, right? So for example, if you have a data coming from top down, right? You have a, like for example, here, if you have a organization called as electronics, which sells TV and portable electronics, then it's a top down approach. Hierarchically, you can split down, go down each of the different levels, right? Let me minimize this. Okay. The first one in the figure on the right hand side. Okay. The second one is called as network. Network type of structured data is basically trees with cross reference. In hierarchical, you have only one-to-many mapping. Okay. Everyone understand mapping, right? One-to-many relationship. Versus in case of network, it may have many-to-many mapping. Okay. Right? Many to one can also happen, one to many can happen. Is this clear? And the third one is called as relational data structure, which is specifically related to your database format, like your any normal database where you have ER diagram, entity relationship diagram, where you have a table which is related to another table through a foreign key relationship. Okay. That's the 3 type of structured data. So the advantages and disadvantages of structured data, I'm just reading it out. Pause me any place you feel like which is not clear. In case of advantages, structured data are easier to formalize in terms of creating data store, developing predictive workflow, and both data loading and processing. It's easier. Okay. Disadvantages, aggregating the query data across the entire database can become very complicated. So if you have many joins and many aggregation, right? Group by clause, right? You put a lot of if then nested type of query, then it becomes difficult to handle and remember, right? And process. Predetermined queries allow exact implementation of user requests. So in case of structured data, predetermined query can be prepared. For example, I want to find the largest of the, or I would call it as, I want to write a query which can give me the top maximum score of student in a class. This is a predefined query, right? I can write select max from table, right? It's a predefined. Versus disadvantage, as the number of data file grows, then the problem becomes exponentially more complex, right? If you have more and more volume of data, the searching takes long time. Okay. Background work of data search is hidden from the user. They immediately obtain the expected result. So whenever you might have worked in data database, what happens? You just write a query and quickly run it. You get a result in the form of a table, right? Right? So you are not shown the background processes and activity that has been performed to get you the results. That's an advantage. So basically in a structured data, or data set or data query, database query, you are not being introduced with the backend efforts or the backend processing capability. In disadvantages, effective maintenance tools is required to maintain data accuracy in a distributed environment known as transactional management. So in case of structured data, the challenge is if your data is distributed across multiple instances, right? Then the maintenance is high because you have to maintain all the system and all the servers, right? Think about in this way. Let's say you have a database in a distributed environment. Distributed environment means, let's say there is a host machine A, host machine B, host machine C, right? Each of the machine I have hosted a database instance of the same database. Instance 1, INT1, INT2 and INT3, right? 3 instances are running on 3 different hosts. Now suddenly a project comes, okay, let's now upgrade the database from Microsoft SQL Server from 2016 to 2019. What will happen? You have to do on all the 3 instances, right? Tool maintenance is difficult, right? Maintenance takes effort and time, right? So that's one of the biggest, another disadvantage. The maintenance tool is required to maintain it. Or if there any package upgrade or any version upgrade is there, then you have to put your effort to upgrade it, right? Advantages, another one is formal presentation of result is understandable. So whatever output you get, it is very easy to understand whatever the output you are getting as part of a query execution. Significant overhead exists to arrange the bunch of required queries. So again, if the query becomes more and more complex, it takes a lot of effort and overhead to maintain and execute it. Okay, so maybe in the current scenario, you might have executed small queries, right? Everyone know what is query and stored procedure? Sorry,
Yeah, we know.
what is stored procedure?
Stored procedure is the query that's been stored to execute.
Sorry,
Stored procedure is the query
query
that's been stored
to,
to the stored procedure that can be executed with the simple command.
okay. In a very simplistic term, a query is a standalone execution of a request. Simple, a query may be select, insert, update, right? When I have to do a bunch of query operations in one go, then I create a stored procedure, right? So if I have to write a query where I have to first pull a data from a table, truncate the table or filter the table, right? And then the next step is concatenate. And let's say I want to do multiple operation with multiple queries. Rather than writing one query and executing in sequential, what I will do, I will declare a stored procedure and package together into a single bunch. So that when I run this stored procedure, automatically it runs all, right? So advantage of stored procedure is when you deploy the code, stored procedure also gets deployed. Versus your independent query is not deployable. I would say you can deploy it, but it is not recommended. So if I tell you there are 500 queries, are you going to write 500 queries in a notepad and then push it every time? That's not good, right? So what do? You will create a stored procedure and write all the query inside it with all the condition parameter and save it. Now, when you deploy the new build, the stored procedure package also gets deployed and automatically it gets run, right? So formal representation to summarize, we can say the structured data works are well in predictable business workflow. So in structured, wherever you have a predictable workflow, the structured data are good. Disadvantage is more consumption of memory is there in case of structured data. Okay, let me explain you. How many of you know about cost CBO? No one knows it. How many of you studied database? Studied database?
Yes, we studied semester, but we didn't get into that concept.
Okay, so cost based. Okay, how many of you understand caching? Everyone understand caching?
Binigay schedule na yun.
Let's say, okay, if I ask one person in this room and I say that, okay, go to that room and bring this data, bring this item from that room number XYZ, right? So this person goes, let's say it's in the A wing or K wing, he goes there and bring that data to me and that item. Next time I ask you to bring that, So there are two options. You go on your own without my help. You know the destination, you go walk anywhere and you pick up that item and bring it to me. The second way is when he was walking all the way, I tracked his way. I navigated his path, how he go and fetch that data. When you go, I pass you that as a template. I give you that as a Xerox copy saying that, look, this person take this route, you follow this route, you will be faster in doing that, isn't it? Cost-based optimization works in the same way. When you query a database for the very first time with a certain condition or query parameter, Oracle, basically in Oracle, it is called as cost-based optimization. In SQL Server, it is called as some other name. What it does, it creates an execution plan. It creates an execution plan. Basically, it tells you that, okay, how this person has or how this query has executed to get you the result, and which all table it search, which all condition it search, it capture that all information and store it in somewhere in form of a cache. Next time when the person requests a similar type of query, it doesn't have to prepare that statement again. Prepare the statement means when you write a query, it's your language. When you translate it to the machine language, it has to prepare it. So it will not prepare it, it will take it a template which has already been used to execute at the faster rate. Right? Only things will change what? Customer information will change, right? Or what will change? Or maybe data will change, right? But the query execution still remains the same, right? If I have to say select Mr. Harish from this table. So there's an execution plan for first. If I tell select test from that table, the process still remains the same, only the data has changed, right? So execution becomes faster, right? In case of cost-based optimization. So in case, like for here to summarize, we can say structured data work well with predefined business workflow. When your business flows are predefined and decided, then the cost-based optimization is optimal and faster and gets you a result faster. But it should be predefined. Okay. The only challenge is more consumption of memory happens because all these execution of cost-based optimization that executes with the execution plan, it happens in the main memory, right? So when the execution plan is cached, so there are many topics in the database, many processes that are running. So those processes consume large amount of data, large amount of memory, right? So that's the reason your performance deteriorates as and when you grow your execution plan or grow your preparation of the statements. So that many times you will see when the database is slow and when you request a DB, will say, okay, let me kill the session, or kill the process which are long running. Basically, what are they?
Record 2179.
Statements which are no more used. Many database handle on its own. Like if the query is long held up for long time and not being consumed, it automatically kills it, right? To generate this enough space for the new preparation of the statements. The important advantage of structured data exists that our data schema address quite adequately and the business need. For user application or anyone who writes SQL query, it would be enough to know the schema to operate with the data. The user has only to know the declared data model. The data is already being translated into data model by the time the user is asking the questions. The challenge is, disadvantage is lack of scalability. Okay. Somebody, can you please mute your mic? Could I mute my mic? I don't know. You all can hear me. Is it echoing? Oh, I'm asking one of the students. Okay. You should specify the name of the student. Okay, then you need to be very explicitly, otherwise you cannot fetch the data, right? Okay, the final thought, obvious flaw in the structured data model is that not all data are structured. That makes difficult to force data to fit in a predetermined schema. That is what most often happens when the data on the web or email or messaging happens. The data is already aggregated, but data cannot be readily split into independent column because you don't know what is the structure of each of the data content. Okay. Okay, so the worst form of data is the text and HTML. I told you, as the complete opposite end of the scale, you have text. Within the text, the data has almost no explicit structure and meaning. Okay, so you don't have any structure and meaning. Yes, any question? Okay. A slightly more structured variant is HTML, which theoretically imposes some form of order by utilizing a markup language that can be understood by the browser. Being a pure technical nature, this structure does not help much as the user with making use of content. So you can although pull out some of the information using tag, but you cannot take out, split the data which is inside the tag, right? In form of structure and structure. However, text remains the most usable way to communicate the content in the context. The World Wide Web is one of the example of fairly large and useful text repository. Okay. The downside of text, at least at the moment, is not, it has no computer understandable semantic content. A human might be able to read it. Again, this is more of a generic statement. We are trying to make machine more and more intelligent enough to understand the text and speech. Okay. Again, this is more of a generic statement. Semi-structured data, again, I have already explained you the example of email, right? Some portion is structured, some portion is unstructured. Obviously, semi-structured data is something between structured data and a plain text. Formal definition is not possible. So for simplicity, we shall consider semi-structured data as a data which ought to have been represented in structure classification, but which hasn't. Means some portion has been structured, some portion has not been structured. For the process of classification, we define a semi-structured data as a data in which one or more of the fields have been parsed into columns. Okay, listen attentively. One or more fields have been parsed into column, not all fields. Okay, so that a semi-structured data email from to, and let's say from to is structured, subject line and the content is unstructured. So from and to can be column, but remaining data cannot be columnized, right? Email is a type of semi-structured data that has many employee and business use regularly. The written content on an email is unstructured data because the computer has no inherent ability to comprehend or organize the text written in a human language. Email application is also gives some inherent structure to the information in each email, such as sender's name, recipient address, recipient name, and date sent, right? Email application also typically characterize message into folder like inbox, draft, thrash, and outbox. Okay, so unstructured, semi-structured data can also be used for finding the phishing emails or some vulnerable emails that will come to your mailbox, right? How does Google identify it as a junk? There's a mechanism behind the screen, right? Some mail is sent to you and automatically it identifies it should be in the junk. Why? It parses the email and it parses the email ID and the subject portion of it, but it doesn't parse the content of it. So if it finds it risky, it will put it in your junk, right? In an organization, if I am sending an email outside my RBC to my personal email ID, what happens? There is a mechanism there that it says that if the email doesn't end with @RBC, it will block it. Or I will get an email saying that the message you wanted to send was blocked. If you want to release it, then you have to raise a ticket to get it released, or approval is required, right? It's because bank is sensitive, right? I cannot send across the data, right? Business can use semi-structured data of email to gain new insight into their customer. Again, an example of it is one of the example is mentioned here. So anyone worked on a ticketing system? Ticketing system, like if you have a problem, help desk, right? Yeah. So whenever you call a help desk, they will give you a ticket, right? So think about you call a help desk and the customer says this is not working, and you say, okay, let me put the information, raise a ticket. That ticket will be assigned to whom? Support guy, right? Technical support guy. Let's say it's an online issue and you are facing an online issue and you want to raise a request with Bell or Roger. You call the Bell help desk and say that, oh, my internet is not working. What will they do? They will raise a ticket, right? Once a ticket is raised, they will assign that ticket to some technical guy, right? So that ticket will go to the support staff who is working in the organization. He will get an email, right? Correct? He will get an email. He will say that, okay, this is the information, this is the customer account, and this is the address the person is facing an issue, right? Now, how the semi-structured data can help? Let's say I'm staying in a house, but I'm frequently having an issue with my internet. Okay, it may happen, right? Your internet may get disconnected quite often, it's unstable. So what will you do? You will call the help desk again that, oh, my internet is still not working. Again, a ticket will be raised, right? Let's say now the ticket is assigned to some other person, right? But the customer account is same, right? Now I want to get an insight after a year to figure it out how many customers are the customer which faces frequent internet disruptions. Because those customers are more likely to change the services, right? Right. So what will I do? What should I do? I should take a ticket from a particular account. That's a structure. I will take an account number, search for an account number which is repeating again and again with a certain time period in 1 year to see whether I get the list of those customers. I don't care about the information that is written there. What I am concerned about is a customer, how frequently this customer is having a problem. So it will give me a insight, okay, this customer is frequently facing a problem. Maybe the locality where the connection is there is unstable, right? So I can fix that locality, right? So that type of insight you can get it. Business can use semi-structured data of email to gain new insight into the customer. For example, a customer service department can evaluate and if a specific customer issue is one-time occurrence or persistent problem, right? By reviewing the content of the email from the last few months, they can then compile numerical data from these emails like the number of error, issue caused, and the average time to resolve it, right? So if one is the issue, once let's say the issue got fixed and again appearing it after 5-7 days, again it got fixed. So we can also figure it out how long it takes to fix it. Resolution time also, right? That's also important. We want to make sure that the customer is not frustrated because the resolution time is more. So I can figure it out to inside, okay, ticket raise versus resolution time. So if the resolution time is higher than the SLA, what we can say, okay, have this reduced because the customer is facing the frequent problem and the resolution time is more. Right? This way we can improve the experience of the customer, right? Semi-structured data, now it is getting easy to perform the following two exercises to split. So what we understood from this example of email, what I am trying to do in semi-structure, I'm basically splitting the data, right? I'm taking the structured portion and then I'm taking an unstructured portion, right? Taking a structured portion and then an unstructured portion. That whole concept of taking a structured portion and unstructured portion is called as splitting the data. So what I'm doing, I'm splitting the data. And once the splitting of data happens, the count of number of messages against each split, I can find it out. Is it clear or no? Number of times it happens, right? This particular concept is called as map reduce. Okay. Don't worry, I will give you more example of it. So to understand here, map reduce has two parts. Any data which you take has got one key and the second one is called as value. Every data content or every data split, any data set you get will have two components. One is called as key, another is called as value. Okay. Don't worry, I will explain you. It's very simple. Just you need to understand how it is being implemented. Okay. Okay, don't read this one. So before we go and understand map reduce, how many of you understand the concept of divide and conquer? What does it mean? What is divide and conquer to, if you have to explain it to someone?
It's about dividing the task or somebody
Smaller
into
portions,
small
right?
components, and then
In
we
project
need.
management also you do. You take a big project and you break it down to smaller work stream and then you further break it down to smaller work item and then you process it. Divide and conquer concept is used in big data Hadoop. Okay. So divide and conquer means I have a huge file, huge file that is a huge volume of data. That source data which I'm talking about is a big data, right? 100 gigabytes of data. I have to analyze and filter out to get a meaningful information. What should I do? One option is I start reading that file one by one. 100 gigs of file is, think about 100 gigabytes of a notepad file. And if I ask you, can you find Mr. Harish inside that document? What you will do? Control F, right? And search it. How long it will take? First of all, your machine will not work, right? Because it will not be able to open that big file, right? Even if it opens it, it will search line by line. If it has got index, still index will search it, right? But index has advantages and disadvantages. Index is advantage for certain cases when the data is structured. If it is unstructured, it's very difficult to implement index, right? So the second option is, let's break that big file into smaller files. Okay, so I have 100 gigs of file, I break it down into 100 small 1 gigabytes of file. Fine, clear? Now I take 100 small set of files are there. Now I pass one program to each of them. Same program. Find Harish, find Harish, find Harish, all of them 100. Now the size file of the size is 1 gigabyte. 100 instances, right? What they have to do? Find my name, right? Number of data to be searched will be less, right? The size is less. Processing will be faster, right? The only thing what I need here is, the only thing I need is, first is split the file, right? First is split the file. Second is how to run it. Correct. How to run the search, right? Because if I take my laptop and take 1 gigabyte, 10 giga, 100 gigabyte of file and take a small file, 1 gigabytes, I created 100 files. End of the day, if I'm running on my machine, still the process is still same. It will eat away my machine's power, right? Instead, if I take 100 small machines, very simple machine of 2 gigabyte, 2 GB RAM, right? Or maybe very small processor i3, very basic laptop, 100 of them, and put 100 each 1 gigabyte file in each of them, and tell all 100 that perform this action. Same action, search my name. I pass the same instruction to all the 100 machines having 1 gigabyte of file. Will it process faster? Obviously, it has nothing to do except my finding my name, right? With 1 GB, right? What two things I am doing? One is splitting the data. Second is putting the data into some machine, right? And third is passing the instruction on those machines. What happens is, if I pass all the machine the same instruction at the same time, it becomes parallel processing, right? So I give all the machine, 100 machines, same instruction, same time. They all will perform on the processing on which amount of data? 1 gigabyte of data, not the 100 one, right? So let's say all 100 respond in 1 second, because every machine has to do only 1 gigabyte of data processing, right? Not the 100. So third part is parallel processing. This concept is called as distributed computing. What I'm doing is, I'm distributing the resource effort of processes on my dedicated slave machine. Okay, this is called as master slave configuration, where one is a master, remaining all other as the slaves, which are low commodity machine. Look at the word I am using, it's called as low commodity machine. Low commodity machine means low performance, low configuration machines. Low commodity means, you understand, hardware, right? It's a asset, right? Right. So I can have 100 VM machines in the cloud of 2 gigabytes of RAM, 20 GB disk space, very minimum 2 core machine. Cost me 20 cents an hour. The cost in the virtual machine of this configuration in the Microsoft Azure cloud is 20 cents an hour. If I host 100 VMs, how much it will cost me? $20, right? It will cost me $20. But how much data processing I can do? 100 gigabytes of data processing I can do at the same time. Only one master will have the instruction, okay, search this name in all the 100 machines. Right? So all of them will search and give me the result. As a master, the job of the master would be to receive the response from all of the 100 machine and aggregate where the data is found. That's it. Okay. So distributed computing is a concept that is used in big data, Hadoop implementation, or any form of big data. 3 concepts are used. One is called as, what is that? One is called as, forgot the word. What was that? master slave, parallel computing, and divide and conquer. Okay, three concepts I used: divide and conquer, master slave configuration, and parallel processing. Clear? All of the three terms you all understood? Divide and conquer means take the biggest form of problem, break it down to the smaller problem. So biggest form of problem is I have a huge data set. What to do with that data set? I don't know how to solve it. I will break the data into smaller portion. That is called as split. Breaking down the data into smaller portion is called as split, right? Once the data is broken down, right, it gets stored in each of the slave machines. Okay. Once the data is broken down, it is kept in each of the slave machine using master slave configuration. So master is the one which controls and tells the slave to hold the files. So 100 gigs of file broken down into smaller 1 gigs of 100 instances. I take that 1 gig and put it on all 100 machines. So let's say 1 to 100 in machine 1, 101 to 200 in machine 2, 201 to 300 in machine 3. Like this, I put all the data in all the 100 machines. Now, once the data is stored, what I have to do? I have to process it because I need to get a meaningful information from it. It is stored. Now I have a program which will tell that, okay, go on all these 100 machines and fetch me this information. The instruction may be finding a name. Same instruction. I need to get the same instruction, but the data is huge, now it is split. I send the same instruction on all the 100 machines. Each of them gets some request. All these machines process the small amount of data and get me back the data. If it is found, it will give me the data. If it doesn't found, it doesn't give me the data. Once the response is received, what I am going to do? I will consolidate it, right? So machine 1 has got data, 2 didn't get that data, 3 got it, 5th got it, 9 got it. I get all the information whichever machine gets the data and I consolidate it. Consolidate means aggregate it, right? Once I get the data, I pass it to the user which needs the request or which made the initial request. Okay, the terminology used in industry is different. Okay, so Hadoop uses the concept of master slave word. Okay, in my organization where I use a tool called as single store, the slave node is called as leaf node. Again, when you go in different organization, different company has a different product. Name will change. So slave is called as leaf node. Master is called as aggregator there. We call it as a master aggregator, MA. And leaf node is called as leaf nodes. Okay, the word changes, right? The concept still remain the same. Now, how does MapReduce program work? Okay, Hadoop basic concept is divide and conquer, parallel processing, split the data and process it. But how to process it? That framework, the process which I told you to search the name, right? To get the name search from those table, that process is called as MapReduce framework, or that program is called as MapReduce. Okay, is it clear? The process, the program that is performed to execute this is called as MapReduce process. Okay, now I will read this and then I will explain you again what does it mean. MapReduce is a framework using which we can write an application to process huge amount of data in parallel on large cluster of commodity hardware in a reliable manner. Okay, commodity hardware means all the slave nodes. Okay, commodity hardware, whenever you are running a big data, always remember leaf node commodity hardwares are inexpensive resource. You have understood, right? It's an inexpensive resource. Why inexpensive? Because the only job it has to do is to get the instruction from the master and execute it. It doesn't have to put any logic, right? Think about if you are a class of 30 students and I am a master as an aggregator. If I give you a file, or let's say if I give you a same book, or I take an encyclopedia and tear out a page from 1 to 100, I give it to 101 to someone else. If I break it into equal part and give it to you all, right? Now, if I give you an instruction, find me this. So every one you will be searching on your set of data only, right? Your set of pages you get. So you don't need to be very expensive and a high powerful machine because the processing capability required to run that small set of data is minimal, right? You are not doing any overhead activity of doing a heavy bulk processing or things like that. And a simple search is there, only you have to perform. Okay. What is MapReduce? MapReduce is a processing technique and the program model of distributed computing based on Java. The MapReduce algorithm contains two important tasks, namely map and reduce. I will explain you what is map and what is reduce. Okay. This is the job which is given by the master to the slave. Okay. That process is split into two parts. One is called as map and another is called as reduce. These two are the functions written in Java. Okay. These are method and function written in Java. The first part of the job of the map is to divide the data into key value pair. Okay, we'll see with the example. Okay. Map takes a set of data and converts into another set of data. Okay. So as I told you, there are multiple slave machines. So when I'm sending a map reduce program, the program when reaches to the slave node. Okay, the program when reaches to the slave node, the first program that reaches to the slave node is called as map. Okay, it's a function, it's a program. What it does, it takes the data which is residing on the data node or the slave node and pick up the data line by line and assign each line data or a word as key value pair. Okay, so as an example, let's say you all have one pages of a document, just one page of a document which is written on your machine, on your hand, right? As a master, the first instruction I will give you is map function to everyone. So what you will do is you will take the map function, you will read the map function say, oh, read the line number 1, pick up every word which is written with you and assign a key and a value. When I say key means, let's say the word is written, my name is Harish, MY stands for key. MY is a key, value is 1. Name is key, value is 1. Harish, name is key, Harish is key and value is 1. So every text inside that sentence in the line is assigned a key and a value. Okay, value is always 1. Even the data is repeated. So let's say the example is a dog run fast and a dog sit down. Just I gave an example. So dog word is repeated twice. Again, it is repeated twice, but the dog is a key, value is 1. Next time it is appearing, again the dog is a key, value is 1. Clear? So everyone gets a file and everyone takes the map function, picks up the word as per the instruction, take a word, put it as a key, give a value. Take a word, put it as a key and get a value. Okay, yes.
I understood your example, but I'm not understanding the fact that why are we giving value 1 to like.
I will explain you. That's the second part of the map reduce. That is a reduction of shuffling, and I will come to that. Okay. So there is a reason why we are giving the value as 1 for every instance of occurrence. Okay.
Then how do you distinguish between two occurs?
That's reduction. We are not going to. Okay, let me first complete it. You will understand there is a reason of having a value always of the same data as 1. Everything, whether it is the same or it is unique, put 1. Any word you get, just put 1. Okay. Basically, we are doing a tokenization. Do you understand tokenization? I'm assigning a token to. Think about it's like a people coming in a ticketing shop, and every time they come, they give the money, they get a token. If 2 people are having the same name, will you give the same token? You give a different token to everyone, right? Same thing happens. I'm passing a stream of sentences, irrespective of what data it is. I don't care. I just say this is the key and this is the value. Okay. The map algorithm contains 2 parts. Map takes a set of data and converts into another set of data where individual elements are broken down into tuple called as key value pair. Okay. Second task is called as reduce task, which takes the output of the map as an input and combine those data tuple into smaller set of tuple. So the second part of the process of map reduce is called as reduction. It's reduce. How it does, I will show you the example. Basically, reduce will do what? Whichever are the same, club it together. So as you said, there are two names, two people having the same name in the text. And A and D and word comes many times, right? So every and I gave 1, 1, 1, 1. Before reduction is also split into two parts. One is called as sorting and other is called as shuffling. What sorting will do, all the ands, A and D, which is coming, merge into one group. Even if it is 1, 1, 1, if it is merged, there will be many and with 1, 1, 1, 1. Okay, I don't have a pen, but again, there is a next slide which will explain you. So, you have a marker? I'll give it. It works, right? It will remove it, right?
No.
No, permanent.
Yes, permanent.
No, I cannot write it to permanent again.
Raising, yeah.
Okay, I'll try. Okay, so let's say. Okay, I'm just giving name like this, right? So this is one key. Okay, A is a key with value 1. Man is a key, value 1, works 1, 1 in 1, man again 1, sleeps 1. Right? This is map function. What is it doing? It's reading the line. It's reading the line. In each line, it finds a word, assign a key and a value to it. 1, no 2, 3, 4. Okay. Now the second step is reduce. What does reduce do? Reduce works into two formats. One is called as sort, and then it is called as shuffle. And then reduce. Basically, it's 3 logical steps. We call it 2 only. So what does this sort will do? Sort will find which all words are of same type. Okay, so here which words are same? Man. So it will group man, 1, man, 1. 2 times it occurs, right? That process is called as sorting. That process is called sorting, like taking out the same word and bringing together in the same place. If it doesn't have the same word like work, it will be here, right? With no instance of it, right? Once the sorting is happened, the shuffle and reduction will do man. How many instances were there? 2. Now it makes it 2, right? The count now gets added. If there are 5 of man, it will be 3, right? So what does this step do? It clubs together the same word which is appearing in the same place into a single group. That is sorting. Shuffling will shuffle it and add it. And the reduction will what it do? It will take all of them, all the 3, and create a final aggregated value as work was 1, man was 2, and was or whatever, A is 1. It clubs it together. Now, if you have this filtered result, it's easy now to figure out where the data is and how many times it is appearing, right? So my basic query here will be very simple to run. So what was this data here? It was an unstructured data or semi-structured data. What did I do? I split it. When I split it, I broken down into key value pair. The key value pair is then sorted, shuffle and reduce. So this sort, shuffle and reduce is part of reduce phase of function. One is the map phase. Map phase only does key value. Reduce phase takes that key value, sort it out into group, and I put the groups of the same data in the one set, and the data which are separate, put it in another group. And the final state is just combine it. The combining activity, this is done by master, and all this work till here is done by slave. Clear? So slave has not to do the full volume of data, right? So think about this is a page of 100 lines or 10 lines. One line is given to one, second line is given to second person, third line is given to third person. and I ask you to do map process. So how much effort you have to do? Only one line each, right? Each of them I will ask you, okay, create a map process. What you will do, you will take one line and split into key value, right? Then I will tell you all 10 of the people come together and whichever have the common thing, just sort it out among themselves. So you will talk to among themselves and say that, oh, I have got this word. You always say, okay, I also have it. Okay, all the word which is related to this come to my group. It's like how you play in the game in the young age, right? What do? You create a group, right? Of the same entity. Now you clubbed it together. Now each of them has got a certain set of group. As a master, once you are done, I'm just saying, oh, come together and give it me all the information. Now I have all the information which is split and sorted. The major advantage of MapReduce is easy to scale data processing over multiple computing nodes. So let's say today, if you want to break into 10 files, 10 systems, 10 slaves can be created. Tomorrow, if you want 50, you can create 50 virtual machines, 500. The biggest advantage is the time you need to run the MapReduce process, then only you need a compute machine. If you don't need, you can decommission it, right? So you can save the cost also, right? Under the MapReduce and data processing primitive called as mapper and reducer, these are two functions that are written in Java. The general algorithm of MapReduce paradigm is based on sending the computer to where the data reside. So this is very important concept called as data locality. Okay, where the processing is happening. Is the processing happening in master or is the processing happening in the slave? In the slave. What the slave contains? Data of your section, right? So data is residing in the slave node. That's why it is called as data locality. Processing in data locality means I am only sending the instructions to you. Actual processing is happening where the data is residing. In a traditional approach, what used to happen? In a traditional approach, if I have to run a query, the query was executed in the main server by pulling the data from all the instances of database. That was time consuming because a lot of network bandwidth was there, right? I was asking for a particular query where all the query has to be pulling out the data from each of the data source and the server took all the burden of executing it. Now in this case, I am transferring the entire burden to whom? To the slave node to do the process. As a master, my job is to only tell the instruction what has to be followed. So it's called as data locality principle. The execution actually happens on the slave node. Master is only an orchestrator or a person who provide the instruction how to do it. Okay. MapReduce program executes in 3 stages, namely map stage, shuffle stage, and reduce stage. Map stage, the map or the mapper job, just remind me at 4:45 that we will pause it and I have to show you the demo. The map or the mapper job is to process the input data. Generally, the input data is in the form of a file or a directory stored in Hadoop file system. So in case of Hadoop, data is not stored in C drive, D drive, or F drive like your laptop. Okay, it does get stored there, but the file system is called as HDFS, Hadoop Distributed File System. Okay, it's like your C drive. Like if you install anything on your machine, Windows laptop have C and D drive in NTFS, right? New technology file system. In case of Mac, you have a different file FST system, right? In case old time, it used to be FAT, file allocation table, right? In case of Hadoop, the file system is called as HDFS. File system means the way the data will be stored in a folder structure. Think about in this, it's not a folder structure, but a structure in which the data will be stored. The mapper processes the data and creates several small chunks of data. Reduce stage, this stage is the combination of shuffle stage and reduce stage. The reducer job is to process the data comes from the mapper. After processing, it produces a new set of output, which will be stored in HDFS. When I'm talking about slave node, data will also get stored in the slave node, in the HDFS file system. Okay, it's not a C drive, F drive. Okay, it's a Hadoop file system. During the mapper job, Hadoop sends the map and reduce tasks to the appropriate server in the cluster. The framework manages all the details of data passing such as issuing task, verifying task completion, copying data around the cluster between the node. So whenever you are doing this map reduce process, someone is monitoring it. The master is monitoring all of the data nodes or the slave nodes, how it is performing, right? If that particular slave node fails, so we can restart that by sending the instruction again. Okay, you understood, right, what I spoke just? Like if you have hundreds of slave node, right, and you pass the same instruction, think about your class is 50 student and everyone given the same task of finding a file, finding a word in the document which individual have it, one student abscond. So I will not get the result of that data, right? So as a master, what should I do? I should call him and tell him to do it again, right? Same thing happen in MapReduce. If a particular process fails, I have to request and see the processing of all of the slave nodes. If any slave is down, I can restart or resend the request to do it again. Okay. Another thing is if master itself fails, that can also happen, right? So what we do is we create a reliability alternate master in the real-time enterprise-wide. Like how we do in our organization, we keep a backup master or two master running in parallel, so that if one drops, the entire system is not disconnected, right? So it's adding more reliability. Okay. The framework manages all the details of the data processes such as issuing tasks, verifying the task completion, and copying the data around the cluster between the nodes. Most of the computing task takes place in the nodes with data on the local disk that reduces the network traffic, okay, which is data locality. Okay, processing is happening on the slave node. In Hadoop, the term master is called as name node. Okay, it's written in the slide. In Hadoop, the master is called as name node, slave is called as data node. Two names are given. Okay, name node is master, slave node is called as data node. In single store, another company like it called as master aggregator or leaf, same concept. Okay, only the name differs. After completion of given task, the cluster collects and reduces the data to form an appropriate result and send it back to the Hadoop server. Okay, so master collects all the information from the data servers or data nodes. Okay, so this one I have already explained you. The input file is provided, it is split into map function. Mapper will map it with a key value pair and the reducer will reduce and club it together. Okay, so we'll see with an example. So this one, all you can read it. I just want to show you this. So let's say if this is an example, okay, I will take the one which is good example, okay, which is the good one. This is the same. So if you see in this left hand side, you have a message. If the message was sent with success S and if it is failed, it is F. Okay, so what will first process do? Now consider that the message is about a success or failure. What it depends is that's a mapping. So what are we doing? Any message, if we see the status as success, we put S. Anything which we see failure, we put F. What I am doing? Yes.
S and F, are these the keys?
S and F are the keys. And what is the value is the data associated with it. So what I am doing, it's a simple example. We will put it in the numerical way. Okay, this is just an example to tell you. So in case of MapReduce, what I'm doing, I'm just putting a key value with success and failure. Then the second step, I'm sorting all the success at one side and failure on the other side. All the success S, if you see all the message with S in up and F with all in the bottom. And now we see how many instances of S are there. I can count it, right? Right, and how many failures are there? 3. Okay. The good example is this one. I will show you. This is the one. This is a good example. If you see here. Okay. So let's assume this is the way you will do the MapReduce program on your assignment. Okay. So see, this is a file data. Okay. So this data has a one line of data called as deer, beer, river, car, river, deer, car, and beer, right? So these are the words, right? Think about this is a MapReduce program running on one master node and one data node, only one. Okay, so what I am doing is my mapper will first read this line, right? My mapper will read this line. What it is supposed to do, whenever it encounters a word, what it will do? It will take a word and assign a key value. So what it does it, if you see in this, first it splits the data into smaller chunks, which as I told you, right? If you have 100 gigs of file, just break it down into smaller. So if this is the file of this size, it's a very small, right? So it basically it says that it will split into 3 parts, right? You may have 100 gigs of file also, right? So the first task will be breaking that 100 gigs file into some level of splitting. Okay, again, the splitting is done architecturally. You and me cannot decide it, okay, split it by 21 gigs. Okay, when an architect design a system, it understands the data format and then it defines the parameter or configures the parameter how much splitting should happen. Okay, should it be 1 gig or should it be 100 MB, something like that, depending on the data value. Okay, so first step is split the data into 3 chunks. When I split the data into 3 chunks, each of the chunks will have certain set of data. Now take each data and assign a key value pair. So if it is deer, beer, river, so deer is 1, beer is 1, river is 1, right? Similar to that, car, river, the second section, again key value pair. Third section, again key value pair. Shuffling does what? Shuffling is basically finding which place this particular word is appearing, in which all nodes or which all split. It just shuffles it and sort it, bringing all of them which are of the same type. When it does it, reducing does it. If the 2 instances are found, it put 2. If 5 is found, it put it 5. If 10 is found, put it 10. Now once it is reduced, it just aggregates all of them in the final results. Okay. So that's the basic concept of MapReduce program. Okay. Yeah, just give me 1 more minute. I just wanted to. So this I already explained you, parallel processing and data locality. Okay. Parallel processing means executing in parallel mode by multiple processes running at the same time. Data computable tool, this all you can read it. Okay. Issue to consider, this also you can read it. Okay, this also practical solution. These are all theory. Okay. This is all theory, you all can read it. Okay. So what we will be doing is we would be running this setup of Hadoop on our local desktop. Okay, on your machine. Okay. So let me show it to you. Other things you can read it. Okay. The concept of MapReduce is important. Okay. So I have a VM machine on my desktop. Okay. On my Mac. Okay. So this is like a window machine to you. Okay. So for a few things you have to do. First is you need a Java on your machine. Okay. Everyone knows how to set up Java. If you don't know, the document is still there. I will just share it with you. You can see my screen, right? So what you will do, you will first install Java. So you go to Oracle site and download Java version. Okay. This is a step that are mentioned here. Set up environment variable. Everyone know how to set up Java home path, right? Set up a Java home path, right? And you put the environment variable, system variable, this you can do it, right? This is a Java installation setup, right? So once you set up your Java, just check the version of Java, whether it is properly mapped to the environment variable and system variable. Okay. Next step is what you need to do is you go to the Hadoop site. Okay. So this is the site Hadoop. Okay. This is a website, your assignment, the URL is given. Okay. So you go to the site. I would recommend to install 3.4.2. Okay. So I mentioned it, search in the Google specifically. So you'll find that location. Okay. So this is JDK environment variable. So this is Java home path. Yeah, this is 3.2.4. If you see my screenshot, right? 3.2.4. Yes, download this one. It's written. You can. I will send you the screenshot. Okay. Use this version to download it. So once you download it, you have to unzip it. Okay. That package will unzip it. Okay. Create a folder in your C drive like this. You all can see my machine, right? Okay, create a folder like this, Hadoop. Okay, whatever is being extracted, just dump it here. Whatever you unzip it, just dump it here. Clear? Once you do that, the next, there are 3-4 steps you have to do it, okay? So first you have to go to this folder, core.site XML. Okay, it is found here in the path of Hadoop, etc Hadoop folder. Yes, so it is inside here, etc Hadoop. Inside folder, this is a core site. Okay, you have to open this in a Notepad++ or whatever you want to open. Okay, right? What you have to do is you have to, I will send you this Word document. Okay, so you have to copy this property section. Can you see this one? You have to copy this, not the configuration line, only from the properties and the value tag. Okay, just copy paste it as it is. Okay, that's a core site XML. Then next step is, like I've just screenshot, I've taken it. Then create a folder which is of 2 folders you have to create in the Hadoop folder called as data. Okay, the folder name will be data. And again, see here, when you create this folder in the Hadoop, create data, all small letter. Okay, within that new folder data, create 2 folders. One is called as name node. Another is called as data node. No fancy name, this name only. Okay, no fancy name. Don't put capital D or a D capital N capital. You need to be very specific with the naming. Okay, when you create the folder, put it as it is the way I have shown you. Okay, once you create it, now you will go to this site, HDFS site XML or HDFS minus site.xml. Either of the file you can take it. It is inside the same etc folder. You see this one? Open it. Open with Notepad++. Okay. Inside this, you will write exactly the same thing which I have written it here. From here to here, properties. If you see what I am writing it, I am writing the place of the data node and place of the name node where it is residing. So if you see name node dot name dot directory, C Hadoop data name node, DFS data node dot data dot directory / Hadoop data node. So what I am telling is, this is my name node, this is my data node. So I'm basically doing a configuration of the master and slave. Okay, so name node will act as a master, slave node will act as a data node. Clear? Then you have to open this MapRed site, copy this content which I have written here, the one which is highlighted. Okay, so Hadoop has one component called as Yarn. We will see it in the next class. Yarn is called as yet another resource negotiator. Okay, so in Hadoop older version, when it was started, if I tell you there are 10 machines and all of the 10 slaves are working, if a particular slave is overloaded, okay, or if there may be sometime the partiality may happen, some node slave may be working very 100% and some node may not be working at all, right? So Yarn act as a person who can control the resource utilization on all the hosts of the data node, so that the resources are equally utilized. That's why it is called as yet another resource negotiator. So when a job is submitted, Yarn job is to see which data node is available to take up the load. So basically, think about 100 students are there, 50, 80 students are working, 20 students are available. So normally what happens? That task is given to them, right? Same thing, we call it as management of the resources. Yarn does it. Okay, so you have to specify Yarn configuration here. Okay, so then you go to the yarn.site XML, you paste this and pretty much, and then 2 things you have to do. Once you have done this changes, you go back to the Hadoop main folder. Okay, go back to the Hadoop main folder, which you have downloaded and extracted inside the Hadoop, right? Delete the bin folder inside it. Okay, entire bin folder, delete it. Okay, now this is the link where I have given you the new bin folder. Okay, the one which you download from the internet will have a bin folder, right? Remove it. Download the bin from this folder, this location, it's a Google Drive. Download it. The reason I will tell you why this folder of bin is required, because it has to be run on Windows machine. Hadoop is built on Java platform to be run on Unix, Linux and Ubuntu machine, not on Windows operating system. In order to make it run on Windows machine, we are doing this. Clear? That's the reason. Otherwise, if you would have to run on Macs or Unix machine, it's no problem, right? But it has to run on Windows, right? Everyone needs it to run it. So you will delete the bin folder, download this bin folder, new one, paste it in the same location. Clear? First delete it and then take this bin and dump it there. Within that bin folder, you will find a file called as winutil. If you see this, right? Within the bin folder, you will find a file named winutil. Okay. When you double click this line, this particular exe, it will throw you a system error, system 32 error it will show you. Basically, it is telling you that this window executable is not compatible with your Hadoop version. Okay. So what you are going to do is, whichever error DLL you get, go on internet and you will search that DLL name. It's a window exe DLL. Simply search that error DLL which you get, you will get it. Okay, no worry. If you don't get it, I will give it to you. Get that DLL, download on your machine and dump it at the same place. Understood? Clear? Once you dump it, double click it, and now it should not give you the error. It should run and it will close it. You will not see anything, but you will not get an error. Okay. The next step, what you do is, once this DLL is done, you need to install Visual C++ redistributable. Again, this is required to run on your machine. So you can get it in this site, just simply download from that executable and dump it on your C drive user system, C drive Windows system 32 folder and dump it there. Okay. This one. Okay. Now, once it is done, you will start the Hadoop by going to that directory, start dfs.cmd. Okay. Once you start it, you will type JPS command. JPS tells you the job process names, how many processes are running. So you should see name node and data node running. Once it is running, you start the yarn process. Once the yarn process is started, you can see the Hadoop running in your browser also. So you can see it like this. If you see local host, right? Right, you see this one? So you should be able to launch the local host like this. And you can see the data node. You can see the application. I think I need to restart it, but I will restart it. So you should be able to see like this in the browser. Okay. I'll pause it here because the next class will start. I will show you the map reduce execution next time, but till this point you will do as an assignment, don't do beyond it. Okay. Install it. If you face a problem, email me. I will help you out. Okay.
Are you going to upload the documents?
Sorry?
Are you gonna upload the documents?
Yeah, I will upload it. I will upload you. Okay. Thank you.